Hello everyone and welcome once again to my channel. This time we are going to be having a series of questions pertaining to organic chemistry for those students that will be writing the forthcoming post-UTME examination. The different areas that they can possibly ask you questions in the world of organic chemistry. So we are not going to waste much time on this, but I would want you guys to watch this video to the very end in order for you to understand how to tackle questions with regards to the world of organic chemistry. So on the board, we are having 5 questions. We are still going to be having more. But question 1, which of the following is an organic acid? Now, this should be taking our minds to alkanoic acids because we have organic chemistry 1 and organic chemistry 2. Under organic chemistry 2, that's where you'll be talking about the alkanoic acids, the alkanols, the alkanals, and the rest of them. So when we say the alkanoic acids, we are simply referring to the organic acids, and they are commonly known by their carboxylic functional group of COOH, meaning that any acid that possesses COOH in its formula automatically is an organic acid. All right. So let's see the options. A, carbonic acid. Carbonic acid is not an organic acid because carbonic acid has the formula H2CO3, and H2CO3 is hydrogen carbonate, which happens to be an inorganic acid. Then for sulfuric acid, which is H2SO4, the sulfuric acid as a word is actually the common name of H2SO4, while that of the IUPAC name is tetraoxosulfate 6 acid. Both of them here, they are inorganic acids. Then option C is nitric acid. Nitric acid is written as HNO3. Then what do you observe? The three of them here, they are not possessing this guy because, like I said, how can you easily identify your organic acids? Is by the presence of COOH. So in these guys, you are not having COOH. So these ones are inorganic acid. Then the last is oxalic acid, which is option D. What is oxalic acid? Now, another name for that acid is ethane dioic acid. Ethane dioic acid. And the formula is COOH duplicated, meaning if I want to represent this structurally, it should be drawn as COOH linked to COOH. So I can as well say that ethane dioic acid, which is commonly known as oxalic acid, is a dicarboxylic acid. What does that mean? It means that it possesses two carboxylic functional group. All right. When an organic acid possesses one carboxylic group, then of course you can call it monocarboxylic. When it is three, it is tricarboxylic, and so on. So the correct option to this question is oxalic acid. It is an example of organic acid. Then let's see the next question. The next question is, the enzyme that converts glucose to ethyl alcohol is, don't be confused about this word, ethyl alcohol. Now, I'm going to explain something briefly. And what's that? Now, looking at that word, ethyl alcohol, might be sounding strange. But one very important thing that you need to know is this, that ethyl alcohol is like the trivial name or the common name of ethanol. Ethanol is seen to be the IUPAC name of the compound. Then ethyl alcohol, look at this. If I write C2H5OH, this is called what? Ethanol. Why did I call it ethanol? Presence of OH makes it to be an alkanol or alcohol. Then C2H5, how many carbons are here? 2. When you see any organic compound with a total number of 2 carbons, just know that such organic compound should start with the prefix "eth". It's just like you looking at the names of the alkanes, the members of the alkanes. Now, of course, the first member is met. You see methane. Now, met contains 1 carbon, eth contains 2 carbons, prop 3 carbons, but 4 carbons, pent 5 carbons, hex 6 carbons, hept 7 carbons, oct 8 carbons, non 9 carbons, and dec 10 carbons. So that's how you go about naming them. So in this case, this guy contains a total of how many carbons? 2. So since it contains OH, then you call it ethanol. But if you look at this guy closely, which is C2H5, C2H6 is ethane, which is a member of the alkanes. And the alkanes, they form alkyls when they lose one atom of hydrogen. So if you remove one atom of hydrogen from alkane, you get alkyl. So if I remove one atom of hydrogen here, I should get a corresponding member under the alkyls series. Meaning that if this guy is ethane, then if I should remove one H from it, it will give me what? C2H5, which is under the members of the alkyls. Then you now remove this ANE and replace with YL. That gives us what? Ethyl. So that's the reason why if you detach this guy is the alcohol, then while this guy is what? Ethyl. So you call it ethyl alcohol. Alright. So ethanol is also called ethyl alcohol. What about methanol? Just follow the trend. Ethanol is ethyl alcohol. Then methanol should be what? Methyl alcohol. That's how it was. And what about butanol? Butyl alcohol. Just like that. Alright. So they said the enzyme that converts glucose to ethyl alcohol, which is also known as what? Ethanol, is, remember that there was a time I treated uh, fermentation in this channel. What is fermentation? A slow microbial decomposition of a large giant organic molecule catalyzed by a series of enzymes to releasing what? Ethanol and CO2. Now, you can carry out fermentation of starch. Starch is a polysaccharide. It can be broken down to maltose, which is a disaccharide, and maltose can be broken down to glucose, which is a monosaccharide. Then glucose can be acted upon by an enzyme, breaking it down to ethanol and CO2, which is, this ethanol is also called what? Ethyl alcohol. So the question is, what converts this to this is what they are asking us. What enzyme is responsible for that? Now, the enzyme that breaks down this guy to this is what? Diastase. And this diastase is supplied by malt. Then while maltose will be broken down to glucose by maltase, and maltase is supplied by yeast. Then while glucose will now be broken down to ethanol by zymase, and zymase is supplied by yeast. So we've obtained our answer now. What converts glucose to ethanol is what they asked us. And of course, it is what? Zymase, which is option C, the correct answer there. Then let's see the next question, question 3. Question 3. A series of organic compounds that have the same functional group with difference in or of CH2 is called dash. Now, you can get that from one of the terminologies that are associated with organic chemistry. And what's that term? Homologous series. What is homologous series? It's simply a family of organic compounds that follow a regular structural pattern in which each successive members of a given series or family differs by CH2. Meaning that first member and second member, what's their difference in the formula? CH2. Second member and third, CH2. Third and fourth, CH2. That's how it works. Alright, so the correct option to this question now is what? Homologous series, because having the presence of this guy just makes it to be homologous series. So let's see question 4. Question 4. The molecular mass of methyl alcohol and ethyl alcohol differs from dash units. This question is a bit tricky, but we can easily get it. The molecular mass of methyl alcohol. What's methyl alcohol? Methanol. Remember, methyl alcohol is also known as methanol from my explanation previously. Then ethyl alcohol is also known as what? Ethanol. So they are asking us that what is now the difference in their molecular weight in terms of this guy and this guy. Now, methanol should be having a formula CH3, which is for methyl, then OH. Then ethanol should be having a formula C2H5OH. Then I have a question. The question is, what can you see about this guy and this guy in terms of difference? The difference is that we increased, this is the first member of the alkanes or the alcohols. We simply increase this guy by CH2, meaning if I bring CH3 out and then I add CH2 to it, I'm going to obtain what? C2H5, which is this one. So if I would want to get the next member, I will still do the same thing here. I will add CH2 to C2H5 to get the next member, which is propanol or propyl alcohol. That should become what? CH2. If I add it now, it gives me what? C3, which is C3 here. Then here should be what? H7, then OH. So if I attach OH, all of them, they have a constant functional group OH. You must attach OH to them. So what's not the difference? The difference is just in the CH2. So subsequently, you should just be increasing by CH2. Then always make sure that you end it with OH. So in this case now, this should be for what? For propyl alcohol or propanol. Then what about butyl alcohol, also known as butanol? I will still increase this guy by what? CH2. That should give me C4H9OH as the formula of butanol or butyl alcohol. So what distinguishes their formula is CH2. And if it is CH2, what is now the unit? What's the molecular mass of this guy? Carbon, what's the relative atomic mass of carbon? Is 12. Put 12 plus what about hydrogen? 1. Since it contains 2 here, it becomes 1 times 2, which will be what? 2. So 12 plus 2 will give what? 14. So it means they differ by what? How many units? 14 units. So that's the correct answer to that question. Then let's see question 5. In question 5, we were told that calcium carbide, because CaC2 is calcium carbide, on treatment with water gives dash. Now, this particular question is coming from the laboratory preparation of alkynes. Alkynes. And of course, the first member of the alkynes is ethyne, having the formula C2H2. That's the formula of ethyne. Why is it having such formula? The general formula of the alkynes is CnH2n minus 2. So if you want to get ethyne, et represents how many? 2 carbons. So N here stands for number of carbons. So if I put 2 here and I put 2 there, it becomes C2 H2 times 2 being 4 minus 2, which would give us 2. So that's how I obtained that formula. So when you react this guy now, CaC2 plus water H2O. Now, they did not add something to this question. They should have said on cold water, because this reaction takes place on cold water, meaning you are reacting this on cold water. The reason is because the reaction is exothermic, so it involves the release of large, enormous amount of heat. So in order for you to regulate that, you have to work with cold water, but that's not even the basic thing now. So let's just carry out the reaction. So when you do that, you are going to obtain the release of a gas, which is ethane gas and calcium hydroxide. Calcium hydroxide. This will be the product. All right. So let's see how we can balance the reaction. This is 1 1, then C2 2, then H will now be 4 over there. So when you make here 2, everything becomes balanced. So this man here is called ethyne. Then what is another name for ethyne? It's called acetylene. Acetylene. And this even happens to be the other name for the alkynes. So the alkynes, they are also called acetylene. And it's also obvious that the first member of the alkynes bears the other name for the family, which is acetylene. So on treatment of this guy with cold water or water gives not methane, not ethane, not ethylene, because ethylene is also called ethene, which is a member of the alkenes, not alkynes. Then why this is acetylene, which is the correct answer, option D. So let's see the next question. Question 6. What is the molecular formula of chloroform? Chloroform is also known as trichloromethane. There was a video lesson I made on that in this channel. You can do well to check. Another name for this guy is called trichloromethane. Now, it has a formula. What's methane? The formula of methane is CH4. So if I say trichloromethane, it means that I've just replaced how many of the H with Cl, because chloro stands for Cl. So Cl I have replaced 3 of this. I'll be left with just 1 of it. So replacing 3 with Cl should be Cl3. Or I can explain using CH4 again, methane. Structure is H, 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 and H. So if I replace 3 of this H with Cl, Cl, and Cl, so I'm having 3 chloros or 3 chlorines. So we call it trichloromethane. So this is the formula of chloroform. So where do you find that in the option? Option B. So that's the formula of chloroform. Then question 7. Question 7. What is the general formula of alkenes? This one is very, very easy. The alkanes, first and foremost, alkanes, which are saturated compounds, they are having a formula CnH2n plus 2. Then alkenes, which are unsaturated, they are having the formula CnH2n. What do you observe? Just remove 2 atoms of hydrogen here. Then you have to obtain that. Then for alkynes, the general formula is CnH2n minus 2. So what's the general formula of the alkenes? It's obvious, is what? CnH2n, which is option A. And as a matter of fact, the alkanes, they are also called paraffins. That's another name for the alkanes. The alkenes, they are also called olefins. Then alkynes, they are also called acetylenes. So take note of that in case you come across other questions pertaining to that, so you know what to do. Then the next question, which is question 8. Question 8. Ethanol containing 5% water is known as dash. It means that if ethanol is containing 5% of water, it means it contains about 95% of itself. Since you are only having 5 in the solution now, you are having 5% of water, and you should be having 95% of the ethanol. So that's what it means. So what ethanol has 95% of itself and the other percent goes to water, of course it is called rectified spirit. So one very important thing that you need to know is this, that rectified spirit exists. Rectified spirit contains about 95% ethanol. Then absolute ethanol, or you could say absolute alcohol, whichever one. Absolute ethanol or absolute alcohol contains 99.5% ethanol. So the one that has the highest percentage of ethanol is absolute ethanol. So I can as well say it contains about 0.5% water. That's for the absolute. While that of rectified spirit contains 5% of water and 95% of ethanol. So take note of that. This thing is very, very important that you should take note of. So the correct answer to that question is rectified spirit from this explanation. So you can pause the video and take down all these. It's very important. Then the next question, question 9. Question 9 says, in a molecule of benzene, what is the total number of double bonds in a molecule of benzene? Benzene has a structure like this. This is the structure of benzene. Is that you are representing it this way, or you are representing benzene this way? Whichever is the same thing. Or you are representing benzene using a delocalized electron cloud. Any of these structures are for benzene. Then, looking at these structures, the one that exposes the double bonds happens to be either this or this. So how many double bonds are there? 1, 2, 3. So we are having 3 double bonds in benzene. So the correct option is option A. The next question, which is question 10. How many hydrogen atoms are present in a molecule of ethanol? What's the formula again of ethanol? Is C2H5OH. All these are questions that when you just see, you don't waste time in the hall. Try to manage your time and then you get your answer quickly. Looking at this is the formula of ethanol. Then they are asking for how many hydrogen atoms, meaning a total number of hydrogen atoms present in ethanol. Now we're having 5 over here and as well as 1. So when you sum up these two, you get what? 6. So a total of 6 hydrogen atoms are there in a molecule of ethanol because they said 1 molecule. Assuming they had said 2, we would have written 2 here, so it will affect everything. But since they said 1, we are going with this, which is a molecule of ethanol. So the correct option is option C. So let's see the next question. Question 11. Which of the following is used to make perfumes as well as flavoring agents? Now, the only family of organic compounds that are commonly used in perfume production as well as flavoring agents because of their characteristic fruity or sweet smell are the esters. So the correct option is option C. Esters, they are also regarded as alkanoids. That's another name for esters. So in case you don't see esters in the option, you can go with alkanoids. The same stuff. Then let's see question 12. Question 12. Which of the following is an example of a hydrocarbon? First and foremost, what are hydrocarbons? They are simply compounds that are made up of two elements only. And what are the two elements? From even the word hydrocarbon means it contains hydrogen and carbon only. What's the symbol of hydrogen? H. What of that of carbon? C. So if it contains any other element other than hydrogen and carbon, then it's not hydrocarbon. So let's check. They said which of the following is an example of hydrocarbon? Looking at option A, chlorofluorocarbon, meaning C, F and C. Now chloro is chlorine, containing fluorine and containing what? Carbon. That's not an hydrocarbon. So this one is out. Then acetic acid. Acetic acid is having the formula CH3COOH, meaning two carbons. Acetic acid is also called ethanoic. So looking at this guy now, this contains oxygen, hydrogen and carbon. But what did I say about hydrocarbons? They only contain two elements, and that is hydrogen and carbon. So since you have oxygen here, this is also wrong. Then C, carbon dioxide, which is CO2. This one does not contain hydrogen, so it's what? Wrong. Then methane. Methane has the formula CH4. So how many elements are here? Two. Carbon and what? Hydrogen. So this is an example of hydrocarbon. Option D becomes the correct answer. Then let's see the next question. The next question is, power alcohol is a mixture of dash and ethyl alcohol. Power alcohol is a mixture of dash and ethyl alcohol. Don't forget, ethyl alcohol is also called what? Ethanol. Remember. So a mixture of ethanol and what would give power alcohol? Now it's a mixture of ethanol and petrol. Now another name for petrol, if maybe for example you check the option, you don't see petrol, you can go with gasoline. That's another name for petrol, gasoline. And what is their percentage composition? For ethanol, it's about 10% to 90% of petrol. So that's how it works, all right? So the correct option is option B, which is a mixture of petrol and ethanol. That's what makes up power alcohol. All right, then question 14. Tartaric acid is a component of dash. Tartaric acid is simply a component of baking powder. Never should you mistake baking powder for baking soda. Now, what is baking soda? Baking soda is sodium bicarbonate, which is sodium hydrogen carbonate. Just this guy is baking soda. Then when you now mix this guy and you mix it with this guy, which is tartaric acid plus baking soda or sodium bicarbonate, because this guy is also called sodium bicarbonate. When you mix both, you get baking powder. So when this guy just alone is baking soda, but when it's mixed with this man, then it forms baking powder. Take note of that. It's very, very important. So the correct option is option D, a component of baking powder. Then let's see question 15. Question 15. What is the dominant chemical present in vinegar? What is the dominant chemical present in vinegar? Now, the dominant chemical that is present in vinegar is ethanoic acid. Ethanoic acid is the second member of the alkanoic acids. Now, we have the first member to be methanoic, second is ethanoic, then third propanoic and the rest. But ethanoic is the main constituent or the main component of vinegar. The common name of ethanoic acid is acetic acid. So option D is the right option. But I would want to enlist the first 10 members of the alkanoic acids and then tell you their common names as well as their sources, so that as for you to know where you can find each of these acids. It will be of relevance to you. In case they would want to twist question on this, then you'll be able to answer the question with ease. So let me just create little space here. Now considering the first 10 members. Now the first member is methanoic acid. Now methanoic acid is also called formic acid, and it is often found in ants as well as bees. Then the next member is ethanoic acid. Ethanoic acid is also called acetic. These are their common names. So acetic acid, and it is found in vinegar. That was how we obtain the answer to the question there. Then the next is propanoic. That's the third member. Propanoic acid is also called propionic acid, and this propionic acid is found in milk. Then the next member is butanoic acid. Now butanoic acid is also called butyric, common name, butyric acid, and it is found in butter as well as human sweat. Then the next member is pentanoic. Now pentanoic acid is also called valeric acid, and it is found in the root of a plant named valerian root. That's the source. Then the next member is hexanoic acid. Now this is commonly referred to as caproic acid, and it is present in the milk of goat, so goat milk. Then the next is heptanoic. Heptanoic acid is also called enanthic acid, and this acid is found in vines, which are also plants too. Then the next is octanoic. Now octanoic acid is also called caprylic acid, and of course it is found also in goat milk. If you observe, all of them, they are carrying cap. Then next is non-anoic. Non-anoic acid is also commonly referred to as pelargonic acid, and then it is found in plants named pelargonium, that's the source. Then lastly, decanoic acid. Decanoic acid is commonly referred to as capric acid, and it is found in the milk of goat as well. So what can you observe about those ones present in the milk of goat? It's very easy. Now this is the sixth member, because if you are numbering 5, then this is the sixth member. 7, 8, 9, and 10. 6, 8, and 10. What do you notice? Common difference of 2. And each of them, they are having cap. So it means there's something common, that they are found in a common source, which is the milk of goat. So just take note of what I've written on the board, and then you'll be able to attempt questions with regards to that. So if you find this video helpful, give it a thumbs up button or a like button, and if you are yet to be a member of this channel, please do well to hit the subscribe button, and you should turn on that notification bell very close to the subscribe button, so that you'll be the first to be notified whenever I upload quality content like this. I wish you guys all the best, and do well to also invite your friends to be members of this community, this great community, so as for them to benefit too. Thanks for watching, and stay tuned as more videos are yet to come.